Every goal that has slipped away, every habit that didn't stick, and every morning that started with no drive, they all share a single root cause. Scientists now understand that dopamine, the molecule most people associate with pleasure, is actually the brain's engine for motivation, craving, and reward-seeking behavior. And the way modern life interacts with it is quietly dismantling the ability to feel focused, driven, or satisfied. Here is what the research actually says about how dopamine controls motivation, shapes habits, and determines mood, and why most attempts to fix low motivation make the problem significantly worse. Most people believe dopamine is the brain's pleasure chemical. That belief is wrong, and understanding why changes everything. Dopamine is a neuromodulator, meaning it coordinates activity across vast networks of neurons simultaneously, more like a conductor than a messenger. It governs motivation, craving, and the drive to seek, not the pleasure of arriving, but the compulsion to pursue. When dopamine is released, the brain isn't registering satisfaction. It's registering desire. It's the signal that something worth chasing is nearby. Two primary neural pathways handle dopamine. The mesocorticolimbic pathway, running from the ventral tegmentum through the prefrontal cortex, governs reward, motivation, and reinforcement. The nigrostriatal pathway controls movement initiation. This explains why people struggling with severe dopamine depletion, like those with Parkinson's disease, don't just lose motor function. They also lose motivation, affect, and the fundamental drive to engage with the world. To understand how dopamine drives behavior, it helps to understand how the brain manages it. The brain maintains two states of dopamine simultaneously. The first is tonic release, a steady baseline circulating throughout the system at all times. The second is phasic release, peaks that rise above baseline in response to rewarding events. What determines the actual experience of motivation and pleasure isn't the absolute level of dopamine. It's the ratio of peak to baseline. Here is the critical insight. After every dopamine peak, the baseline drops below where it started. The higher the peak, the deeper the drop. This is the biological mechanism behind every post-achievement letdown, every feeling of, why don't I feel as good as I expected to? Every pleasure that fades faster than it should. Research measuring dopamine responses across different stimuli makes the stakes of this visible. Chocolate raises dopamine to roughly 1.5 times baseline. Sex elevates it to around 2 times baseline. Nicotine reaches 2.5 times. Cocaine also 2.5 times. Amphetamine drives dopamine to 10 times baseline. An elevation so extreme the subsequent crash is physiologically catastrophic. What this data reveals isn't just which substances are dangerous. It reveals that every spike has a proportional cost paid by the baseline, and the baseline is what determines the experience of everyday life. This is where modern behavior becomes a significant problem. The brain's dopamine system evolved in conditions of scarcity, foraging for food, uncertain outcomes, intermittent rewards. It was never designed to handle the level of constant stimulation modern life provides. But the deeper issue isn't the existence of dopamine-spiking activities, it's the habitual stacking of them. Consider a common scenario: working out with a pre-workout supplement, listening to music, texting between sets, and filming progress for social media. Each of those elements triggers a dopamine response. Layered together, they produce a combined spike far beyond what the brain was designed to handle from a single activity. The workout itself, which would otherwise generate a healthy, sustained dopamine response, is now competing with and being overshadowed by artificial elevation. The result is gradual baseline depletion. The activity itself starts to feel unrewarding without all the additions. Then the additions stop working as well. Then the baseline drops low enough that even formerly enjoyable activities produce little to no pleasure. This is hedonic adaptation, and it operates silently, usually attributed to burnout, mood problems, or lack of willpower rather than its actual cause. Research illustrates the endpoint of this cycle clearly. In one clinical case, a young person experiencing severe inability to concentrate, low motivation, and complete loss of interest in previously enjoyed activities was evaluated for ADHD. A 30-day period of complete abstinence from the highest dopamine-spiking behaviors, social media, video games, constant phone use resulted in restored concentration, improved mood, and renewed interest in exercise and social connection. No medication, no diagnosis, dopamine baseline recovery. The neuroscience also explains why attempts to solve low motivation by adding more stimulation consistently fail. What the brain needs is not more peaks. It needs the baseline to recover. Research published in the Proceedings of the National Academy of Sciences found that extreme dopamine elevation from substances like amphetamine and cocaine reduces neuroplasticity in the prefrontal cortex and nucleus accumbens, limiting the brain's ability to rewire itself in response to new experience. The tool that was supposed to increase motivation actually impairs the brain's capacity to find anything motivating. So what does the science say about protecting and rebuilding dopamine baseline? The most consistently supported finding is the power of intermittent reward schedules. The brain's dopamine system was built for variable outcomes, not guaranteed rewards. When the same activity is paired with the same enhancements every time, the system habituates and baseline erodes. When rewards are unpredictable, the motivational circuitry stays activated. Randomizing which sessions include music, caffeine, social engagement, or other enhancements, rather than always using all of them, preserves long-term motivation better than consistent pairing. Caffeine occupies a unique position in dopamine research. Unlike stimulants that directly spike dopamine release, caffeine works primarily by upregulating dopamine receptors, specifically D2 and D3 receptors, as identified in research by Volkow and colleagues in 2015. Rather than flooding the system with dopamine, caffeine increases the density and efficacy of receptor-binding sites, making whatever dopamine is naturally released more functionally available. This mechanism explains why regular caffeine use doesn't produce the same baseline depletion pattern as other stimulants. Cold water exposure provides one of the most striking illustrations of the difference between spike and crash dopamine and sustained elevation. Research published in the European Journal of Physiology documented that cold water immersion produced a dopamine increase that rose gradually, reaching approximately 250% above baseline, and remained elevated for hours after exposure ended. This is the physiological opposite of what drugs, social media, or stimulant stacking produce. The mechanism is fundamentally different. Sympathetic nervous system activation, triggering catecholamine release in a way that builds steadily rather than spikes and collapses. Perhaps the most practically significant finding concerns the relationship between effort and reward. The prefrontal cortex, responsible for meaning assignment and cognitive framing, directly influences dopamine response to activities. Research supports that deliberately associating dopamine release with the process of effort, rather than exclusively with outcomes, changes time perception and sustains motivation across longer timeframes. The work itself becomes the signal, not just the result. Dopamine is, as researchers have described it, a currency. Every peak is a withdrawal. The experience of motivation, drive, and satisfaction in daily life depends not on how high the peaks go, but on whether the baseline remains healthy enough to make those peaks meaningful. The paradox of modern dopamine culture is that the pursuit of more stimulation, more enhancement, and more intensity progressively narrows the range of things that can produce any feeling at all. The science points toward a counterintuitive conclusion. Protecting dopamine means learning to seek less, not more, and finding that the activities which remain are experienced more fully than they ever were before.